All right, these are two line reactions from the old exam that you sent me. So this is just question 1, C and D of the old exam. So we'll go through C first. What you should be thinking is we have this aldehyde and a base that is going to deprotonate the alpha carbon, leaving the electrons in the carbon, and so now the carbon can't act as a nucleophile. And so they didn't give you any other reactants, they just gave you this aldehyde, and so it's just going to be a reaction of the aldehyde with itself. So I'm just going to redraw the aldehyde here, and now we just have to think about when those two aldehydes react with themselves, what is going to be the product. And so if you want, I can draw through the mechanism again, but you have this nucleophilic carbon that's going to attack the carbonyl carbon of the next aldehyde. Electrons are going to swing up, and that's basically all that happens. So let's just redraw. This is how I always draw it. I think it's the easiest. Let's just redraw the aldehyde here that's attacking, and I'll label it out for you there. And there's going to be a new bond between carbon 4 of our attacking aldehyde and then the carbonyl of this aldehyde on the right. So we'll just make a bond from carbon 4. I'm just arbitrarily numbering this just so you can keep track of your carbons. And so there's a new bond and so this looks sort of funny, but you basically just have to count your carbons. So I'll number it here. So we said there's a new bond between carbon 4 of the aldehyde on the left and then carbon 1 of the aldehyde on the right. If we look in our product, that's what I've shown. The bond is between carbon 4 of one aldehyde and then carbon 1 of the other. And then look at what is, so in this reactant here, what is bonded to carbon 1? You just have a hydrogen and then carbon 2 and an oxygen. So carbon 1 here we have a hydrogen, carbon 2, and then the oxygen. And so you don't even have to draw in this hydrogen here. And then just the rest of the aldehyde chain, 2, 3, 4, 5. Yeah, all right, let's go on to D. We're doing a similar type of reaction here. So first, LDA is going to deprotonate the alpha carbon. We only have one alpha carbon in this ester. That's going to deprotonate that carbon, making it a nucleophile. Second step is adding in this ketone. And so same thing, what's going to happen here, nucleophile is going to attack the carbonyl carbon, electrons are going to swing up. So I'm just going to exactly redraw the ester, new bond between the alpha carbon and the carbonyl. All right, so let's number this out so you can see it. And I'm just arbitrarily numbering again, 1, 2, 3, 4, 1, 2, 3, 4. So it's carbon 2 again, which the alpha carbon, which I've labeled carbon 2, is a nucleophile. It's attacking the carbonyl carbon of this ketone, which I'll just number 1, 2, 3. And so just keeping track of your carbons, carbon 2 of this ketone here is bonded to what? It's bonded to an oxygen, a carbon, and a carbon. You just want to make sure that's still what you have, an oxygen, a carbon, and a carbon. And the reason why this is an alcohol here in the product is because they have this workup step. So usually when these electrons here, when the electrons swing up, that would just be an oxygen with a negative charge on it. But since we've added in this HCl workup, it's just gaining the hydrogen there.